So I invite Professor R. Srikanth, who will be chairing this session. He is Professor in Dean School of Natural Sciences and Engineering, NIAS.
Okay, thank you. I think hopefully we'll have all the seats filled up soon, and I think we have got a very short post-lunch session at Bengaluru, and before we have our coffee to wake us all up. So we'll start this session without much ado. This session is on basically understanding the state of knowledge. And since it's already, I really appreciate all the people who are actually joining from abroad, because I think it was past 2 o'clock in the US now. So I think I would first like to make a small deviation by inviting Dr. Steve Monsga to speak first, and then after that, Mr. Yogesh Tewari will start. Dr. Steve, over to you.
Okay. So my goal today is to talk some about tracking emission of greenhouse gases and ozone-depleting substances using atmospheric measurements. I'll give you a flavor for what we do at NOAA and within the US and globally. And I know some other folks are going to follow me to also describe a little bit about what other activities are ongoing and approaching people by other countries and other scientists around the world. So, much of what I'll talk about has been touched upon already by some other speakers. I'd just like to first start with a background about when we talk about long-lived gases, ozone-depleting substances, and greenhouse gases. Those are the global emissions from sources. I think Dr. Terasowa can read those emissions on that map, or read those measurements on that map were global in nature. I think that's what she meant here. That's how I interpret what she said there. And that regional emissions can be quantified with atmospheric measurements made near the sources, so within countries where emissions are occurring. And I think, in my opinion, atmospheric-based emission estimates on both scales support inventory-derived emissions. They provide an estimate of the sum of all emissions, and it's changed over time. We're looking at global background concentrations and how they're changing over time. And they also can provide independent estimates of emissions on regional scales, that is, independent from inventory-derived emissions. On regional scales, for example, national scales, they can confirm magnitudes and trends for well-characterized systems, and they can point to areas for further study when discrepancies are found. It's also been mentioned that the NIAS reporting of greenhouse gas emissions has historically relied on inventory-based methodologies, but the updated recommendations for 2019 include the considerations of atmospheric-based measurement methods for supporting inventory accounting and enhancing understanding of greenhouse gas emission magnitudes. And the coming together of these two approaches is also important for the Montreal Protocol and ozone-depleting substances, so not just those issues related or those gases related to the UNFCCC. Dr. Terasowa showed a map. Many of the stations that she indicated on her map are also places where no one makes measurements. Once again, it's this remote atmospheric sampling network that provides an understanding of global atmospheric changes for long-lived greenhouse gases, ozone-depleting substances, and it's from that information that we can drive global emission rates for those long-lived gases in kind of a budgetary analysis. You can see that one particular region, over the US that is, where the measurements, or the density of the measurements is quite enhanced, and from that measurement network, we attempt to derive US emissions of these same gases, ozone-depleting substances and greenhouse gases. And we have a number of different techniques at these different sites around the world. Dr. Terrasola also showed this map. We didn't collaborate on this, the presentations, but many of these same points are made from the remote atmospheric measurements. We can derive global atmospheric changes and concentrations for the main greenhouse gases and also for the ozone-depleting substances, and those concentrations and how they're changing over time, how they're responding to any policy changes on a global scale. So when we're talking about attribution of global emission changes by region, our ability to do that is quite limited for Montreal Protocol gases. And I call those Montreal Protocol gases, when I say that term, I'm meaning CFCs, chlorofluorocarbons, hydrochlorofluorocarbons, and also the hydrofluorocarbons. So our attribution of global changes is limited on regional scales. We're using atmospheric data. In fact, it's limited to essentially about 3 regions around the world. Across the U.S., where we know are making measurements. Across Europe, a number of organizations make measurements regularly of these gases. And then in Eastern Asia, there's some capability for understanding concentrations and how they're changing over time and what they imply for emissions. So you can see that significant gaps exist. I think Robbie may have shown this, or a version of this figure. Significant gaps exist in our understanding of regional contributions to global emission magnitudes and changes. And I think one of the reasons we're here today is to understand whether or not we might be able to fill some of these gaps, an important gap here in particular that represents India. I'll also mention that currently inventory reporting for the UNFCCC is also incomplete because only certain countries are reporting estimates of emissions to UNFCCC. And for the hydrofluorocarbons, this reporting actually only accounts for 50% of global total emissions. That's represented by this figure where the sum of hydrofluorocarbon emissions are plotted over time. And for our budgetary analysis on a global scale using background atmospheric measurements, global total emissions have increased quite dramatically over time, as represented by this blue line. But what's reported to the UNFCCC in total HFC emissions is quite a bit lower because only a portion of countries are reporting to UNFCCC. So if things were to change in an unexpected way, you wouldn't necessarily know where those changes were coming from. This gap in our understanding of global HFC emissions, this is indicated for a few years ago, around 2016, and an updated analysis that I don't have right here at hand has indicated this gap has only gotten larger since that time. So Robbie also mentioned this issue of CFC11 that I think, and I agree with him, that demonstrates the importance of atmospheric measurements in support of international agreements to provide an independent estimate of whether or not things are changing as expected. This is a picture of concentration changes of CFC11 over time since 2010, since global production is banned by the Montreal Protocol. We have results from northern hemispheric sites in red, southern hemispheric sites in blue. And you can see that after the ban, we expected the concentration to continue to decline, at least at the same rate. Instead, we see that the concentration decline slowed. Well, this didn't make sense, and in fact, it pointed to the presence of increased emissions and most likely increased use and production of this chemical that had been banned by the protocol after the date that it was banned. Now, emissions, considering the map and where we can characterize emissions on a regional scale, looking at those maps and looking at the data that we had, this slowdown in the concentration decline was attributable in part, about 60%, to emissions that had increased in eastern China. But the remaining emission increase was not attributable given those gaps in the network. we announced this finding in 2008. Unfortunately, since that time, concentration decline has rapidly accelerated. So the issue appears to be mostly resolved by now, although currently concentrations are still enhanced now compared to what we expected before. This is a picture of the emissions derived from these global trends. We can see that they were increasing unexpectedly after 2010, and since more recent years, they've declined quite a bit more rapidly. And once again, thinking of this example, I think it demonstrates the importance of atmospheric monitoring, the power of observation for assessing compliance with international agreements in concert with the inventory-based accounting methods. So what does it look like in the U.S., this atmospheric-based greenhouse gas and ozone-depleting substance emission quantification? This is our network of sampling sites across the U.S. where we make measurements either from tall towers on a daily basis or less frequently from aircraft in a profile. Samples are collected, measurements are made in our lab. They're collected mostly in class where we measure 50 to 60 different chemicals in each sample. And here I've shown just an example of the results for hydrofluorocarbon 134A from a number of sites in California. This is 12 years worth of measurements of this chemical where on the westernmost site, or from the westernmost site, we see fairly consistent measurements from one sample to the next because this site is receiving wind from the west, from the fetch over the ocean, where there aren't emissions. And yet move a little bit inland, and we see large enhancements in the concentrations due to nearby emissions. And it's these enhancements observed at these other sites that allow us to understand and infer emission rates nearby. So regionally California-based, Oregon-based, Washington-based emissions of these chemicals. Once again, we measure a suite of greenhouse gases, ozone-depleting substances, and others. So we use that enhancement information, combine it with inverse modeling methods using Lagrangian techniques to derive emissions over the U.S. given that sampling network that I showed. We do derive ostensibly emissions at 1 by 1 degree resolution. You can see these emission maps for two different chemicals, an HCFC and an HFC, over the U.S. and how they're slightly different foods and their different distributions depending on the use patterns of these different chemicals. They make some sense in that regard. We can also aggregate to regional scale. Here's a key to the regional scale in the central North Howe for in this region of the country. We have enhanced emissions of the chemical often used in insulating of buildings against cold weather, whereas chemical used for cooling and air conditioning is enhanced in the southern regions of the U.S. So this information we bring together as global totals or regional totals, or we can also derive seasonal variability. And as Phil mentioned, in this example for SF6, all of that information is very useful to use as a starting point for discussions with inventory folks to understand whether or not there's limitations in the atmospheric emissions, where they're being made, the process by which we're making them, or whether or not there are limitations and uncertainties in the the bottom-up inventory analysis. And so we've had very fruitful discussions and learned a lot about processes involved in involved in emissions of these gases through the combination and collaboration of these communities. Now, there's only a few countries that currently their emissions from atmospheric-based approaches in the National Inventory reporting, and we were fortunate enough to be invited to do that by the EPA in the 2022 National Inventory reporting, and we did that for four HFCs. HFC 134A on the left panel here, the atmospheric-based results are in solid lines, and inventory is in the dashed line. And for the three lesser abundant or lesser emitted HFCs, and we can see that there's some nice consistencies for some chemicals, but not for all of them. And while consistency is the goal, because ostensibly that could mean that we understand the system quite well, finding discrepancies and looking for discrepancies can lead to better overall understanding of emissions, more robust, more defensible emission estimates, and a more comprehensive system for monitoring mitigation policies going forward in the future. So just to summarize, I hope I've to you made clear that the existing global greenhouse and ozone-depleting substance emissions monitoring network, both at NOAA and at other organizations around the world, can provide estimates of total global emissions for long-lived non-CO2 gases that influence climate, that influence the ozone layer. But it does have substantial gaps regionally, such that global emission changes can't be fully attributed on a regional basis, and this limits our understanding of global changes, represents a substantial vulnerability if global changes are unexpected, and prevents an independent assessment on regional scales of emission mitigation efforts. There are always limits to the information available from that sort of data. So I think it's important to stress and emphasize, and others have made this point, that making progress necessitates a close collaboration between these two communities, the atmospheric measurement and inventory pilot communities. And progress becomes much more likely, and we learn that much more when these communities work together. And this is just a few future needs here, from my perspective anyway, as a scientist, and that's enhancing the sampling network, enabling more robust state-based emission estimates for the U.S., and enabling emission estimates for other regions of the world to try to fill some of those gaps, to grow the collaboration between atmospheric science and inventory communities. And there's a number of technical issues that could be improved and worked on to provide better estimates of emissions of the U.S. And with that, I'll close. And happy to call for your opportunity.
Thank you, Dr. Steve, for staying up so late to present your valuable insights, and thank you for sticking to the time. So now we go to the next speaker, that is Dr. Yogesh Tiwari. I think Dr. Steve basically mentioned that it's a gap in measurement in South Asia, and I hope that basically you will be able to explain what IITM is doing and what India is doing to address this gap. Thank you. Over to you.
Yeah, thank you, Steve, for just preparing the ground for the observations. Indeed, we have started not long back. We have some observations, but not HFCs, CFCs. So can you share my slide? So before that, I would like to thank Dr. Beg, Professor Shailesh Nayak for organizing this such a wonderful meeting and inviting us, and my good friend and buddy, Professor Phil Ducola, who is currently sitting in Paris and then attending, and then he was supposed to be here, but due to some technical issues, some visa issues, he is not here, but hope he will visit us very soon. Okay.
We can't hear the discussion online right now.
It's mute.
Are you guys muted in the room?
I think so. Yeah. Yes. Now it's okay, Phil.
Yes, you're back. Thank you.
Yeah, thank you. So before that, I was giving acknowledgement to all here and then to you that you are the person who should be here, and but sitting in Paris and discussing with us. So thank you very much to you, and hope we will see you soon in India. Yes, please can you show the slide? Yeah, okay. So, okay. Sorry for this technical issue, online attendees. Maybe it will be resolved soon. No.
Accept and continue. Click on the PDF. Click on the PDF. Accept and continue. Go down. Yeah, accept and continue.
This was,
Yeah. Maybe you can say Control L, so it will become PowerPoint mode. Yeah, right. Yeah, thank you. So, as topic given that India's capabilities in situ GHG measurement. So, can you see Phil? Can you see the slides?
This is the local presentation.
Select the screen. Screen left side. Achha.
Yeah, right. Can you see the slides, online users? Okay, thank you. Okay, so I'm going to present basically the in situ observations that we have started at Indian Institute of Tropical Meteorology, as well as I'll show what are the capabilities currently we have. So can you go next slide? Maybe Control L if you put, then you can do that easily. Just Control L. Yeah, right. So I wanted to make the stage just showing this slide because this was long back published CO2 emissions due to fossil fuel emissions in South Asia. So this is the time series of CO2 emissions due to fossil fuel combustion and cement production from all the South Asian countries between 1990 to 2009, and then a lot of changes must have come. So you can see all the countries from Bhutan to Sri Lanka all are there. So, and then blue line is India, and then black line is total. So it is very clear that we are the big brothers in this continent. So we need serious note on observations. Next. And this one, this is taken from the Ministry of Power. So this is CO2 baseline database for the Indian power sector. And the two pie charts, the left one is 31st March 2005 report, which is basically the breakdown of power generation capacity covered by the database, and then you can see that the 55% of power was generated using coal in 2005, and this number became 70% in 2021. So, and the reduction happened over the hydro. It was 26% in 2005 and now 16% in 2021, and rest almost all are same. So it means we are losing somewhere, but putting everything on the coal because it's a much cheaper power to use coal. And as Sunna Bhattacharya madam said that 42% of power generation is from non-fossil fuel sources. This is in 2022. So this is close to 1,47,000 megawatts. It is compensated basically from the non-fossil fuel sources. It comes almost 42%. But overall, this the amount of coal is increasing. So this is very latest report from the ministry, 31st March 2021. Next. So what we need observations. So this is our current GHG observation sites in India. And I am showing here not only the in situ concentration monitoring, but also the flux measurement in different ecosystems. Starting from IITM Pune, so we have a site in Kaziranga National Park in the reserve forest for flux monitoring. We have site recently in Aries Nainital, and we have site in central India, that is Tal Tower site. I will show you some pictures. And we have site in Pune, and then close to Pune, there is one mountain, it's called Asiaga. We started long back, almost more than a decade ago. Also, we have site in oceanic features, for example, Port Blair, Lakshadweep, and then down you can see the Pichavaram, that's a mangrove site. So, star marks are given, there we have an in situ concentration monitoring, and where a star is not there, it's a purely flux monitoring. From NRC side, actually it is NRC IRS, there are the site I was discussing with Professor Badwal, who's sitting here, that we have almost 5 sites. I showed here just 3. One is in North Barkot, Batul, and then Sundarban. And we have 3 sites from IAA, and then 4 PI, that is earlier CMAX Bangalore in Hanle. It's a site higher than the Mauna Loa, so it's started at some time in 2006, and then it is still running. And they have one site in Pondicherry and then one in Port Blair. And we have 2 sites from NARL Tirupati and 1 site from PRL Ahmedabad, that is Mount Abu. And IMD recently started a site in Rani Chori. Dr. Soni is here, so who is in charge of this site, who has initiated this. And we have site at Aries Nainital from Manish Naga and group. They have published recently one paper. And recently one site is started from IIT Delhi from Dr. Ravi Kumar. He is measuring these gases just outskirts of Delhi city, somewhere in Sonipat. He has a tower. So overall you can see this is the capacity currently overall. Maybe 1 or 2 sites maybe missing, I may not be knowing, but this is overall 80-85%, 90% sites are there. And the variables which we are measuring, it's a CO2, CH4, N2, and then carbon monoxide. So on the name of greenhouse gases, we are measuring only. So there is no CFC, HFC which is measured. Next. Our capability is basically is to we have started with the flask, and in 2009 sometime, end of 2009 at Srinagar, it is in Western Ghats. You can see top left, we have a tower over there, and we have initiated in situ monitoring with sophisticated instruments, which is basically endorsed by the WMO and these people. And we have purchased calibration cylinders from NOAA's WMO protocol. So we are doing observations under the WMO protocol umbrella. Recently, we have started one site in outside of Bhopal. It's basically it's a village where IITM has a 2 meter, and then it's India's tallest tower for the GHG monitoring. So it's called a test bed. I'll show you the picture, but before that, I wanted to tell that we are monitoring almost entire species from soil to atmosphere, from greenhouse gases to isotopes, and then we have a flux monitoring, and we have soil CO2 monitoring and multi-level AWS, and then we have radiation measurement and everything we have. Next. So this is recent visit to the site. So you can see the top picture. Director IITM visited there, and it's just a very huge huge setup and 100 acres of setup. And down picture you can see this picture is taken from the radar building. So it's a completely open fetch, 72 meter tower and 100 acre of land. So this is site now. Now it's in place and it is running. So maybe next few years we'll have very valuable data from here. Next. And we have done some airplane observations using our instruments. So we have put it, and then we have monitored many years on campaign mode, few months every year, and then it was really a fantastic observation. It was very useful for the model validation and this thing. Next. And we have done some ship campaigns also in different sectors. This is just one example that we have done in Bay of Bengal, which was published. And other than that, we have done some ship campaigns in Arabian Sea and then in Indian Ocean also. So this also is repeated every 1 year or 2 years. Next. So I wanted to show you some brief results. Next. So this is methane CO2 time series, which is basically from the flash sample. You can see 2009 it was started, and it is still continuing. This data is shown in 2019. So you can say that the trend for the CO2 methane is almost 5 ppb per year, and then for CO2 is almost 2.7 ppm per year. Next. This picture shows the very high frequency monitoring of CO2 and methane. It's every second monitoring, and we have inducted our in situ monitoring in somewhere in 2015, and which is continuing. And then you can see the data which is coming along. It has a large fetch, and then it really captures the local as well as the larger scale signals. Next. This is very important plot. We have started isotope monitoring recently, maybe in last 3-4 years. So we are measuring delta 13C of methane and CO2, and then we have compared two different techniques, two different instruments. This is in the left top, if you can see, it's a delta 13, it's a CO2 carbon dioxide from the two instruments, and down it's delta 13C of two instruments. Why we are measuring? Because these isotopes are basically used to understand the different sources. So we can partition the different sources using these isotopes. Next. We have not only the delta 13C, and also we are measuring delta 18O of CO2. Basically, it's not only 18O but 17O also. So this plot shows the variation between CO2 delta 13C and then CO2 and 18O. Next. So you can see in this plot it is measured delta 18O and delta 17O. Why it is important? Because basically when we have isotopic fractionation, so when plant does photosynthesis, they keep the heavier isotopes 18O and then they release, evaporate lighter isotopes. So basically for understanding carbon water nexus in different seasons in India, particularly in monsoon, such kind of atmospheric observations are really important, and these observations are really continued. This is just example I showed. Next. This is profile of the aircraft that we have done over IGP region in 2014. This is methane. You can see the top left is aircraft in September, and then right side in middle it's a one model. It's the chemistry model. CAM. We have just validated the model. I'm showing one example that how powerful these observations are there. We are using these observations in further for the modeling, for the estimation of the emissions, but these observations are really useful to understand the model dynamics. So model vertical transport, which is not understood, there is no data vertically. Next. This is carbon monoxide during the same period, and then it is used for the model validations. Next. Yeah, this is a very peculiar plot. Actually, I have tried to understand because when we were flying the aircraft, these aircraft were made for the cloud monitoring, and then we thought that let us see if we can categorize the polluted and non-polluted clouds using the carbon monoxide observations. So we have found that those clouds we are enriched with a lot of carbon monoxide. So those are basically the polluted clouds, and which those they do not have carbon monoxide. They are basically clean clouds. So basically the clouds are getting the transported emissions from the convection, advection, and then those carbon monoxide really sitting within those also. Next. Yeah. So this one is CO2 flux monitoring. As I was showing you that at different locations and different ecosystems. So this is purely a tower-based point observations at different locations. This is carbon sink on the y-axis, micromole per meter square per second at different seasons. So the site you can see it's a Bepul, central India, and then Barkacha is basically IGP region, and then over Kaziranga and then Sundarban and Pichavaram. So this is just comparison how the CO2 flux monitoring are shaped in different ecosystems in India. And then we have information how our forests are powerful in sequestering the emissions. Next. So we have a model simulations activity also. It's recently started, just last 5-6 years. So basically it's a top-down approach, means it's in situ monitoring plus inverse modeling. Next. So we have done collaboration with NIAS Japan, and then we have developed a NIAS IATM transport model at IATM. So our main motto is just to utilize all the observation. This is a global model. All the observation which we are doing in India, just to develop a model so that we can take this ahead. So this is not, I will not say that this is only, so many other groups are involved outside all over the world who are doing, like for example Anita Ganeshan is also involved, and then she has done so much modeling over the Indian domain using the observations. So this is just IATM effort. Next. This is just one example that when we have used our observations in this model. So this is seasonal cycle of terrestrial biospheric CO2 flux resulted from the cyclostationary inversion. So what we have found that when we used the Sierra observation, such observations were not used previously. This suggests that an overall source of temperate Eurasian terrestrial fluxes. So Eurasian terrestrial fluxes basically where India lies in that area. So this magnitude of 0.19, so as opposed to minus 0.23. So you can say that when there was no observations, it was like a 0.23. It was showing like a sink and with a large uncertainty. But when we used the observation, it became a source 0.19. So I will not say that these are the wrong, because we were not using any observation. But after using observation, it became source. But there are some informations. Next. And it is very useful in the uncertainty reduction. That's a major part. When there is no observation in the inverse model, we have a huge uncertainty, more than 50%. So it's a 50-50. But when we use our observations, so we could reduce the uncertainty basically up to 30%. So that's a great thing, that if we have more observations in the model, then uncertainty is reduced, and then we can more believe in the top-down approach models. Next. So we have given input to policymakers basically for the BUR reports. Next. So this one was basically prepared during the BUR 3. Left side you can see that BUR 1 and 2 lines are given, and then Edgar is in red, that is interselementary, and then top down, which are estimated by our model, it's a yellow line, that's a 12-month running mean. And right side we have used our airplane observation to compare, validate those models, those optimized fluxes, which really shows that the strength of the model and how model is powerful. Next. This paper is from Anita Ganeshan, she is here, and then this paper was really, it was liked by the ministry people, and then they have just used in their BUR reports also. You can see the black line is estimated by the ministry, by the MFCC, by their activities, and then the blue line is by the estimations using the top-down observations, and red is from the EDGAR. So it was estimated from this paper that it was almost EDGAR overestimates almost 30% when we really see from the observations. Next. So this was just a BUR report, and then where we have utilized not only the surface observations, but we have used the aircraft, we have used the satellite, and this it was like a combination of observations in Lagrangian multiplier. Anita may discuss about such kind of work next. Yeah, so this is take-home message. I will not go in detail, whatever I said, that when we use Indian observations, then it is going to be very useful for the estimations, and it really, it's a very value addition of those observations, and it clearly says that when we have observation, then we have a more faith in our report. And also last point, if you see that flux monitoring site, it's a Kaziranga National Park, so acted as a net source in 2016, but a moderate sink in 18. So our ecosystem, it's not that every time they are acting as a sink, because so many things are playing a role. There are grasses, there are soils, and then so many others are there. So we have found that it was source, but it was moderate sink in 2018. Thank you very much. I think last one. Yeah, thank you.
Thank you, Dr. Tiwari. So we will now move to the UK scenario, and before that I think I have Dr. Suma.
Morning.
You have printed me twice.
Yeah.
Thanks for the honor.
Okay. So we'll go, I think we have saved some time, whatever we lost in the beginning. So we go to UK to Dr. Alistair and Dr. Anita from UK.
Actually, excuse me.
Yeah.
I was mentioning to Fufan earlier that these colleagues are available for supporting the discussions, but there wasn't any specific presentation to be made at this point in the agenda, so we could have discussion here and they can participate as needed, but there was not a presentation, a further presentation. We mentioned quite a bit about what UK is doing already in my presentation and in others. So I think that's already been presented, and now I think they are available to participate in discussion.
It is discussion.
Should I add something?
You have to come here. You have to come to the mic.
Yeah, so Vinay Dadwal, NIAS. I just thought since this was an India presentation and Dr. Yogesh had really covered a lot of work, I'll just add three more things. One, at NRSC Shadnagar, we measure through FTIR the columnar CO2. That has been done almost like last 5 years or so. Parallelly, on ground, we use Picaro to measure both carbon dioxide and methane. And incidentally, NRSC has a data reception in Antarctica, so there also we have established the CO2 monitoring. So this is in addition to, we use environment-based monitoring for diurnal CO2 half an hour at about 7 sites. More importantly, the variability in the ecosystem for GPP and net carbon exchange has not been properly sort of coming from the samples which we have taken. So we are covering tropical dry deciduous forest, we are covering a moist deciduous forest which is Sam, and we are covering mangrove. 3, in fact we have 5 and 2 are the C3 and C4 crops. So our general average is coming annual carbon fixation, GPP of the order of 18 to 21 ton, and the net of the 4.5 ton. So this I thought, and one of our site has been running for more than 7 years. Thank you.
Yeah, thank you, sir.
Thank you, Dr. Adwal. I think, Phil, you have got something to say?
I have a question for the previous speaker. I was curious to know more about the common CO2 measurements, what kind of spectrometer was being used, and where is the location of the unit?
So the location is in Telangana, a place called Shadnagar, that is 25 kilometers outside the city of Hyderabad. So it is a suburban cum rural site. It is a data reception center of NRSC, where I used to work for some 5-6 years back. And there what we have done is we have established a separate building. On the top is the FTIR, and also we measure at the ground also. So we basically have 3 types of measurement, and very nearby we measure fluxes over a dry grassland.
Thank you very much.
Dr. Anita, you have a question or comment?
Hello, yes. It was a question for Yogesh. It was very nice now to see all those new sites, lots more since we worked together 5 or 6 years ago, so it's really nice to see. So I was wondering, what is the protocol on where that data is compiled? Is it shared? Is it publicly posted somewhere? What is the thinking on how that data might be coordinated and shared?
Yeah, Anita. The data which we have published, like our flask measurement, they are already open, so it is used by many researchers. But the data which is started in situ basically 2015 or 16, that we are in process of publishing, because once we publish it is easy to cite the data. So once we publish this, of course, it is open to the researchers, for example, for you, inverse modelers, just to utilize this data at different locations. And the Central India side, our tower side, of course, we have started maybe another 1 or 2 years or 3 years line. We have a very good data for the researchers just to come ahead and then use it. Yeah.
Yes, please.
Sorry, I had a similar question. Does some of the international agencies like WMO or NASA, do they know that you are doing such activity? Are they aware of the kind of efforts are being put, though they are in the beginning, early stage?
Yes, sir. At least on the WMO platform, we have presented this kind of work many times, and then WMO knows. But the thing is, we have not shared this data on the platform which WMO has. For example, World Data Center for Greenhouse Gases, which is basically run by GAW, and then WMO under that control. So because for that, we need a permission from the ministry, because this data, if we put it on international platform, we cannot do by our own. So this is, of course, this is in proposal. I cannot say anything on this platform, but for the research purpose, yes, data is already available. For research purpose, we provide the data. Yeah.
Ask a question. Okay, maybe it's for Yogesh or anybody else. I thought IITM was putting together a data center. Is that not true?
Putting together?
Yes, having a data center which would essentially...
yeah, right.
Is that available now?
It's not implemented. It's just another proposal. Yeah, it's not implemented. But data center, once it comes, yes, it will be there. Yeah.
Just one quick question, if I may, moderator. So the published data is available, right?
Yes.
So
yes.
The one which you have published is available.
That we can share.
Okay.
Yeah.
Dr. Anita, Dr. Phil, do you have any further? Dr. Phil, I think you raised your hand.
Sorry, it was just a follow-up to the data question. Once it's been published, and I totally understand that you're publishing the method and all those details, will there be a plan to sort of update that data every 6 months or something, so that it's continually being uploaded to some server somewhere, even after the initial publication?
Well, I mean, we have atmospheric data center in IITM. We have made it, but it is not fully functional. So once this data center is fully functional, we'll put entire data on this in easy format so that people can use it based on their science proposals if they provide, and then they can always use it. Yeah.
Dr. Phil, go ahead. Yeah.
Thank you very much. Yogesh, one of the things, first of all, that was a wonderful presentation, lots of rich material and work being done. One piece of work that I'm familiar with of yours that you didn't show is looking at some of the nodes in the subcontinent. You've done work to look at the inverse footprints that would be across the 4 main seasons in the subcontinent, what kind of sensitivity those locations would have to emission estimates. And it's very exciting to see those locations, in particular the Bhopal location, where you have a very, an area that meets a lot of the criteria we've been talking about. For example, it's not immediately in the source region, but near source regions. It's serviceable in terms of atmospheric transport modeling because of its flatness. The tall tower permits good atmospheric transport modeling also for the fact that you're getting up into the upper parts of away from the near surface. And so, wondering, one of the things that we could talk about in terms of where we might go from here with this consortium is testing out some key locations in terms of their value for India as those ongoing locations for F-gas, in particular for F-gas, since we're already seeing some consensus emerging that F-gas is a good place to start in terms of building trust for top-down plus bottom-up activities. So wondering if you could say something about the potential for making some samples from, daily samples from the Bhopal Tower that could be analyzed in the laboratory and test its value for emission estimates.
Yeah. So, Phil, let me clear this point that taking a sample and sending outside the country is sometime opposed.
Yeah, I'm not even thinking about that so much. It doesn't matter about I'm not thinking the details about where such samples would be analyzed. I'm just thinking about the value in terms of that location for emission estimates right now and some approach to testing it and some other locations that you showed on your map also.
Yeah, well,
you have begun to investigate yourself.
Yes. We have done some Lagrangian modeling and then we have used some sensitivity research, and we have found that some network of station in India, and we have given a number that how much uncertainty reduction will be there if we use our observation over here. And this paper was published just 1 year before last year. So we have found really this site as a very useful. But unless you are saying that if we have observation over here from sampling or from any other monitoring, so the observation should be on site so that if you put some spectrometer online mode, in situ mode, then it is possible always. So I am just open for the observation if it is done at the site, and also the potential of the site. As you are saying that it is really very open question. We have done it, but I would really appreciate and I would really thankful if a group like Anita and then like her colleagues, they also can involve in her future research and then see the potential of the site. And it's really, you are saying that it's really because it's not near the emission, but it's not far from the emission, almost 60 to 65 kilometers outside the Bhopal city, and it's a kind of a semi-urban environment, but it's very interesting site, and we have a profile of gases. Yeah.
it would be a great opportunity to demonstrate some of the things we're talking about and to start building trust about the value of such activity. And then I think you're right, Yogesh, at some point, whether or not we haven't talked about the instrumentation that's needed for the F-gas concentration measurements. You talked about the Picaros and the LGRs for CO2 and methane, but we haven't talked about gas chromatography, mass spectrometry, GCMS, as it's abbreviated, which is something that I believe India has worked with in some laboratories, but not for the purpose of halogenated industrial gas concentration measurements. So whether a laboratory would be established for that work, or to begin with, some Indian scientists would go and do training at laboratories doing these kind of measurements already around the world. It's a topic for a detailed discussion at a future meeting, I think. But for today, I think it's just interesting to think about the value of a place like the facility you've established in Bhopal, which is very exciting, and to think about a way of building up some knowledge and trust about the value of such a place, I think is exciting.
Yeah, correct. Yeah, let me add just two more points, Phil, because if we talk about the GCMS, then we have a capacity at few locations. For example, ISC Bangalore, they have a very good group who have a mass spectrometer they are running, but I am not sure if they are measuring HFCs or any F gases or CFCs, but they have a good capacity and then they have good expertise. Also, the Physical Research Laboratory, PRL Ahmedabad, they also are expert in isotopic measurement and they have a mass spectrometry. So if in future, if we are planning, so we can bring these institutions on board, and then always we can set up the laboratories there. Yeah.
Yes, I think one of the things that I'm beginning to see as a conclusion is the need for a technical exchange meeting that would come sometime, next, following, as a next step coming out of this meeting. And in such a meeting, the scientists who do such GCMS measurements inside India could meet with those who are doing it for F-gases in other places, and there could be a valuable technical exchange.
Yeah, perfect. I agree with you. Yeah. Please go.
Yeah, I'm coming from a totally different perspective. I don't want to go to the gas chromatography and locations and specificity of it. Suppose a journalist would like to give a headline, may not be on the front page, but maybe inside science page, saying that IITM has initiated measurement of greenhouse gases at following locations. And its objective is this, and it will slowly start publishing this data, which will be accessible to the general public as well as journalists and other scientific institutes by this and this time. Without going into the bureaucracy that unless the ministry gives a permission, we won't do that. And that sounds like a never-ending story. But you can say that by this time we will start publishing it. Is it possible to prepare such paper and give it to me, so that give it to journalists?
Yeah, generally, sir, our target is just to retain the data for 1 year when we measure. So till 1 year we try to publish it and then open to the researchers for the research purposes. So this is our current policy. And the data we have already published, this is, of course, it is open, and then we can say that, yes, it is available for the public use. And for the data which we have not published, we don't want to open because it is hard to cite that data if you are writing something and then if you are preparing some document. So first we publish the research for that, and then we open for the researchers. This we can say that.
Yeah, two quick comments. Yes, it is wonderful to have more eyes on data so people can do something about it. But we shouldn't forget the sociology of science. People who make measurements should have an opportunity to mine the data to get, so you do need a certain amount of time to make data public unless it's completely established as an update. For two reasons. One, for making sure that the data is quality controlled. And number two, the people who are putting the work must have an opportunity to get some recognition for it. Okay, so we shouldn't forget that part. It's pretty important. So the second point I was going to say is that I think at this meeting, it would be better not to mix up the need and the desire with specific modalities of how things are going to be done. If you go that route, I think before you actually have established kind of what is the desire, what you want to do, but if you get into all those nitty-gritty details, it's very likely we're going to get derailed along the way. Just a word of caution. Thank you.
So thank you, Dr. Ravi. I think we had a very interactive discussion session this time, and so now we'll just
the information that's needed, that should be developed, how could India's policymakers use it? What is the information that managers and policymakers need, and what information can be provided by science and technology for now and in the future? So to sum up these 4 or 5 lines, it's basically the fact that science needs to build up its communication skills with policy making and industry. That sums it up. Now, we have a wonderful list of panelists covering a lot of the industry in air conditioning and refrigeration departments, as well as, of course, the scientists. And may I just say one thing, that having been at Cambridge University these last 3 months and engaged with a lot of the scientific community in the UK and other parts of the world, it seems to me that the real problem is managing the actual data that science has produced. It's not that science has lacked data, but it's actually the data that has been produced and researched needs to be framed in a manner in which it actually emboldens industry and policy making in a way that they can't leave the room. We have to keep them engaged as major stakeholders in everything that you do. And I was just talking to a lot of my colleagues in the air conditioning business and refrigeration business, and they all viewed the same sentiment. And now I give them the chance to express their views. We begin with science and have Mr. E. Arunan from the Indian Institute of Science to start his panel talk.
He has spoken earlier.
Oh, he's spoken. So you have then Mr. T.K. Mandal, who's with CSIR NPL, who can start the process.
Oh.
Mr. Mandal?
Yeah. Let me first introduce myself. I am Dr. Prem Kumar Mandal. I work mainly as a scientist at CSIR National Physical Laboratory. I must say that CSIR NPL is NMI, probably the NMI in the sense National Meteorology Institute, and I am also basically in the R&D also, and I have some association in the industry as a chairman of the BIS industrial gas. So my submission will be two way. One as a scientist and for the CSIR NMI, as well as some of the part of the chairman of the BIS of the industrial gases. So there is a four question. One is basically what information is needed and what should be developed. I basically go categories one by one. Probably Dr. Tiwari has given a good map of the atmospheric science measurement of the greenhouse gases. I could find myself also somehow work out because I could say that the NPL also doing the measurement in the Himalayan region for last 7 years. That data is missing. So the basic fundamental part is that, in fact, the measurement part, and in NMI, basically as NMI, we talk about the quality measurement. Quality in the sense quality and the precise measurement. So in the NMI, and one of my as a divisional head, one of my section is basically dealing with the gas meteorology. So the first point is I talked about the data sharing and information sharing. So India do not have the right now doing the information sharing over the measurement and of the atmospheric sciences data for the greenhouse gases. So probably that Dr. Tiwari has opened the paradigm, and then I think this consortium should take in one view that there should be a kind of forum where the information about the atmospheric measurement must be there. The second point is the trust. Probably the trust comes from the actual measurement and precise measurement. I just said that the actual and precise measurement comes from the standard, because when we do the measurement of the standards, all kind of equal standard, probably we can go for the calibrate that, then we can see the trust. I probably share one of the information with the this here, that there was a misconception about the methane emissions from that is in rice paddy field, and my supervisor Dr. A.P. Mitra was now known here, but he started the measurement from there was the information from the international community that India produces the large amount of methane from the rice paddy field, I think 34.6 teragram, and in that time it was at the 1991 the measurement started, and there was a misconception about the measurement, and then the Max Planck Institute and NPL they shared that information. As Dr. Sprint said, that the sharing of the sample, probably we still do the PT, that is proficiency testing in our NPL. We do share the samples within the institute, in India, even within our outside India. We share the samples and we do the measurement, and we say that what is our calibration and measurement capability. That's why we do that's why we establish the trust. So probably the trust can be basically done, which is required, that by the sharing of the samples and sharing the information. And the next point is the activity data. Probably I could see that this discussion in the presentation, that a lot of information is not missing because of the activity data. Probably the activity data, real-time activity data has been basically shared. That I find that if we do not have the real-time activity data, and that will be the major gap of in the part. So that has to be shared. Second point, the emission factor. And I was hearing one of the presentation in some of the meeting. I could find like oil and gas. In that case, I could find the 16 area where we are basically missing the emission factor, and the actual we are still adopting some of the emission factor. So probably we should have the emission factor, and that should be shared with our measurement and the emission factor. Now, what should be the development? Development is basically the strong collaboration between the strong collaboration must be there between the team of between the team of the emissions inventory and the measurement and the industry. As the chairman of that is the industrial gases of the BIS, I could find that there is a standard for the different application, different gases. So that's why I find that must be shared when we go for the policymakers. That must be information. Once we do that, probably industry will also be benefited, our policymaker will be benefited, our measurement and also the emission inventory, when we prepare, it will be basically benefited. So this information must be shared, and now I'll go to the next part. That is, what information do the managers and the policymakers can need? The data amount of the concentration. There is a gap Because gap in the sense, when we do the measure that basically in the concentration, we do not deal with the emissions. So dealing with the emissions and also the emission inventory. So that the trend pattern, when you do have the trend pattern, then in the case policymakers can take the data and do some kind of update, and using the update they can say that what kind of we are doing. So the measurement and emission pattern can be basically identified and can do the job. So one point I'm missing here, that is called how could the Indian policymakers use it. So any changes in the data sharing part, like in the emissions as well as the concentration, it should be dealt with properly. Otherwise, basically, we can go. Policymakers can end up something where our measurement will get gap. So that gap must be settled. And the last point I must inform that what information can be provided by the science and technology sector now in the near future. Probably we know that when we deal to the ODS, then we give the replacement of the HFC. And then now today we are thinking that HFC is basically greenhouse gas. So when we are dealing with the new technology, we must be aware of that what will be the fallout of the new technology. The government of India taking a lot of activities in the solar panel, and also the hydrogen missions and the EV, that is electric vehicle. Probably the technological development must be shared. Technological invention must be shared, and also the fallout must be shared. I could share one information because at the Solar Alliance, one of my colleagues who is doing the dealing with the solar cell, and you know that when we use the solar cell at a certain period of time, it's basically the R&D. I'm not going to the part, but there must be thought process. And then when there is a solar cell, and after a certain period of time, the solar cell panel will be basically not in use. So you have to throw the solar panel somewhere else. So what will you do with the solar panel? You have to either dissolve or you have to burn it. And we did some of the solar panel burn it. I could find that there is a lot of chlorine is coming out. So probably when you're dealing with the science and technology, we must also know what kind of technology we are giving that. So that should not be the problem for the future. So that's my basic submission.
Thank you, Mr. Mandal. I think it was, you gave a very open and frank.
Hello. So anyway,
You gave for the institute or for your company to go forward in any manner. So unless data is available, and it needs to be real-time data, it cannot be multi-decadal. And I will say one thing openly to all the scientists over here, with due respect. I think one of the failings of the IPCC, most of the reports, almost all, is that most of their data is multi-decadal. And this is why we find ourselves in the predicament that we are in. It needs to be augmented into real-time data. That's so critical. And I thank you, Mr. Mandal, for highlighting this. Can we now have Mr. S. Gunde from IIT Chennai? IIT is the premier institution of our country, and it makes us proud globally, always.
Thank you very much, and good afternoon, everybody, and greetings of the day to my fellow panelists, those who are online there. My name is Sachin Gunte, and I am a professor of Earth System Science and Environmental Engineering at Indian Institute of Technology in Madras. Although I directly do not work in the greenhouse gases, I basically am an aerosol scientist, but I would try to draw some of the parallels which I have learned from my experience, particularly related to the measurements, and then as the honorable moderator has told and given me the topic, I just try to touch upon certain points which my predecessors have said in the morning, and I take one from Ravi where he said that, not knowing its own emission essentially leads from the emission gap, basically, which means that we do not really have a measurement, and that's something which I, as an experimentalist, I always
felt upon that even as basic as sometimes even a hindrance in the basic methodology data has kind of cost us a lot of good quality papers. So one of the things which I do believe that for the policymakers, we as a scientists can bring in is that the robust measurement, and then this has to be robust and systematic measurement, which we have to do. And then why these measurements are important, again, I would like to quote Professor Ravi, who said in the beginning, is that just to show the world that usage doesn't necessarily mean emissions, right? And that's for to kind of put it in a positive perspective. We need to have the measurements, right? Again, I'll quote it from the example which Oksana showed, that you have the measurements all across the globe, but then obviously over India, we did not see any specific measurement points as far as that is concerned. What I do believe is that since now we have come up to this stage, and then I would like to thank Professor Baik to kind of bring in all the experts on this platform. Maybe we could, it's really a time to ponder upon a thought that why not to have a specific working group of all the policymakers, scientists, and then my industry partners are also there, right? So this is just one of the ways to go forward to bridge this gap between the policymakers, the technology, the researchers. What do they basically need in to have some sort of a working group? And what this working group could essentially think of, or to again discuss about, is that how these, how each member of this working group can contribute and then take that message further down to really up to the regional level. So, for example, except modeling, I may not be able to contribute at this moment about any sort of a greenhouse or ozone-depleting substances. But one example is that we have a laboratory in Munnar, which is in the Western Ghat at 1,600 meters, and it really serves as a background location. So, as compared to any other laboratory which you have, particularly in the southern India, our laboratory is a landmark in the sense that you could use it as the background site. So this working group idea could really be in a way that each member of the working group can pledge to do that. The other thing is that what I do believe is from the previous experiences that the regional representation in any sort of this consortium or any effort is equally important. So let's just suppose hypothetically I imagine that, okay, there is some sort of a working group which is kind of mandated to have this kind of a measurement. So really up to the state level, the involvement of the engineering colleges or the science colleges or any other institution which is kind of working in some sort of a research area is the lowest hanging fruit, and then would provide a lot of returns if we try to involve them. And then it has a two-phase benefit out of it. One is that you obviously spread the awareness through outreach to these institutions about what we are discussing here and why it is important. And then the second thing is that once we give them some sort of a facility, obviously the returns are generally very high, because these people really look for this kind of an opportunity to contribute in whatever way they could be. The other thing is that since my industry partners are here, and then I myself have got benefited being in IIT through the corporate social responsibility. So as far as these monitoring networks are concerned, at this moment I do not know what could be the modalities, but what I see is that the involvement from the industry, particularly through the corporate social responsibility to establish the monitoring network or to add any sort of a value to the consortium, and then if they are part of this working group, I believe that the moral as well as the cause would be highly uplifted if we have the industry partners right from the beginning, not only for the corporate social responsibility per se, but even understanding the technological requirement. And last but not the least, what I would really say is if such a working group indeed exists, right from the beginning, as Ravi mentioned in the beginning, and if I'm not wrong, I think Professor Phil also mentioned that in his talk, is that we need to kind of not to throw this data at the policymakers, but then to start from the very beginning that how and which way these policymakers would like to use the data, but that something remains as an approach where we are not having the clarity. But why not to really go to the policymakers in the the beginning itself and then say that, like, look, what is that you would like us to bring it to the table so that we could really use it to the fullest and then see the outcomes at the last moment. One of the things, just as a concluding remark, what I think is that our efforts also to be pointed towards amplify as well as speed up the efforts, right? I mean, since we have now started, we probably can't afford to say that it is going to take your own time, but that probably one thing which, although I'm a physicist but being in an engineering institution, what I learned is that anything which has a natural solution, the job of the engineer would be to amplify and speed up the solution. So in that case, since we have now come up to this level, probably not to have a breather, but then to keep pushing this agenda to really amplify and then as well as speed up our efforts. With this, I would like to thank particularly the NIAS for having me here, and it is really indeed a pleasure and privilege to be part of this esteemed gathering. Thank you very much.
Thank you, Gunte. You gave a brilliant suggestion, which I think is very useful going ahead, and that is the application of CSR, corporate social responsibility, towards industry and policy making, which is really lacking. I think all institutions such as yours were privileged to have philanthropic funds and foundations contributing towards the maintenance of education and being a breeding ground for new technology. We need many more such institutions in our country, because these are the institutions which will then sow the seeds to enable industry to empower and embody themselves continuously with new technologies which are evolving. The next speaker is Sumit Prasad from CEEW, and you may take the floor, please.
Thank you, sir. Greetings, everyone. I'm Sumit Prasad from the Council on Energy, Environment and Water, and I lead the climate negotiations team at the council. Just to briefly, discuss the importance of this consortium, I think it's the need of the hour at present, right? Considering that we have agreed to the Paris Agreement obligation of the enhanced transparency framework, the reporting obligations to the developing countries is going to enhance drastically. Although we do have the flexibilities, but then we need to prepare ourselves to be able to report on those things. And on that very note, we at the council are working on the capacity building aspect of the transparency, right? So coming to the information that we actually look forward towards understanding the capacity, there's two critical questions that we always, try to answer. The questions are capacity for whom and capacity for what. This is really important considering as we move forward with monitoring of the greenhouse gases emissions over the available years, because if you know that, that these are the institutions being involved in the entire process, that is the capacity for whom, right? But then what exactly is the technical capacity that we need, right? It is the state of the art, it is the technology that we need, it might be the modeling capacity that we might need, and how do we maintain them? Like, what is the institutional capacity that's needed? What is the legal framework that is needed? What is the financial capacity is needed? Basically, the enabling environment of this entire system needs to be cleared and needs to be brought, information needs to be gathered on these fronts as we move forward in this entire direction of strengthening this GHG reporting as well as ODS reporting, right? I think it's really important that we give some clarity as we move forward on these fronts, and also, when we really talk about identifying the capacity, we need to be very cautious about the two things, right? We and India has a very large democratic system compared to the other countries across the globe, right? We are like more than European region in terms of when it comes to covering of this entire reporting systems, right? So we need to understand that our capacities would be limited, and how do we leverage about innovative way towards reporting on these GHG emissions is really important, right? So I think this is something which I would like to just limit my conversations right now, and happy to hear from the experts today. Thank you.
Thank you, Sumit. That was quite enlightening, although it was a bit brief.
Sorry.
But thank you all the same. We now move on to Mr. V.K. Soni from IMD. Take the floor.
Yeah, thank you, sir. Good afternoon. I'm V.K. Soni from, I am Head of Environment Monitoring and Research Center of India Meteorological Department. And I have a few points to make, and as we know that India is an Article 5 country under the Montreal Protocol, and India is already taking proactive measures to curb the ODS and GHG. India was mandated to phase out CFCs by 2010, but the production and consumption of CFCs phased out in 2008 itself. So our emissions are also just like that of Article 5 countries, low emissions for CFCs and high emissions for HCFCs and HFCs. And all these Montreal Protocol related policy measures and control measures are being taken by the ozone cell of Ministry of Environment and Forest, and we do work with them closely. Our mandate is to monitor the ozone in India, and the Ministry of Environment and Forest has taken several measures. India is the first country to bring out the India cooling action plan to reduce the cooling demand and refrigerant in India. And as India is a signatory of Kigali Amendment, it has to begin phase out the HFCs also. But one concern is that we still do not have proper monitoring facility in India, particularly the ozone depleting substances. GHGs we have developed some kind of capabilities, but ODS this monitoring is still completely missing. And we found that there are many countries where we found that the measurement-based estimations differ with the bottom-up approach quite significantly. So both the bottom-up approach and top-down approach is very much required for estimation of ODS, GHGs, and HFCs concentrations. And regarding one more thing regarding this emission inventory, the time has come now to think about the highly resolved dynamic emission inventories rather than the conventional emission inventories, and then updating it, reviewing it every year and modifying it by some kind of emission factor like that. So we should now think about this dynamic emission inventories. And one more thing that we have not discussed in this forum right now is the food loss and waste that contributes to staggering 8 to 10% of GHG emissions. So these are my submissions. Thank you.
Thank you, Mr. Soni. Again, we heard the consistent cry for the need for emission monitoring, bottom up, top down, and the importance that it plays going forward for everything that our policymakers and country do. You mentioned about food waste and the emissions from the dump sites, which is also a very important factor, which can be addressed because that's purely methane emissions mainly. But I think there's a potential to deal with that separately at a different forum. I now am delighted to call upon Mr. Gaurav Metani from the industry. He's with Daikin Air Conditioning, which is one of the global leaders in air conditioning systems. And it will be very interesting to get his industry perspective for a change in the room. So it's a breath of fresh air. Good luck, Gaurav.
Thank you, sir. Thank you, NIAS, for inviting me and giving me this opportunity to be amongst this August gathering. I'm very happy to be here.
So those who don't know Daikin, globally we are a $25 billion organization. We are a world leading organization. In India we have almost 6,000 crore turnover with almost 10,000 touch points. So globally, Daikin majorly emits two kinds of greenhouse gases during the production and the development processes. CO2, which is largely from the energy use, because we are into air conditioning products, and for information, we are the only brand which produces air conditioning, refrigerants and compressors in the world. And the second one is HFCs, where we have almost 10 years back moved to R32 refrigerant, which is a low GWP refrigerant. Though we have taken a goal to be a net zero company by 2050, but we have also taken a new goal to reduce CO2 emissions by almost 1.5 million tons, which is almost 40% lower than what it was in 2015. We believe that there are many ways to reduce CO2 emissions by reducing energy induced in CO2 through development and production, which I already touched upon, by reducing CO2 emissions during transportation, because that is another sector which is there in ICAP also, and also we are largely using energy efficient transportation to bring the CO2 emissions down, and using renewables. However, India case is a bit different because of a couple of other parameters which I will touch upon. And talking about CO2 emissions, I think India moved from an efficiency matrix of 3.1 to 5 now, which is almost 60% higher. If I talk about the standard labeling program, which all the manufacturers, including Daikin, follow that. And to the current 5-star efficiency, I strongly believe that still there is a more room to go above that efficiency by almost 25 to 30%, where we can look at CO2 emission reduction. And the prizes which recently got concluded, one of the prizes was Global Cooling Prize, where India demonstrated the capability of achieving 40% than the current 5-star air conditioners efficiency. So that capability. And also talking about R32, which is a low GWP refrigerant, India has now started using almost more than 90% of 32 in room ACs is being used in India, and of course the commercial AC category still are using R410A largely, but I think research is on for it to use alternate refrigerant, because it has a high risk of flammability because of they use largely more refrigerant in the air conditioning system. But I think one of the points which I want to touch upon, where actually the data is needed, because everybody is focusing on finished good energy efficiency. I think it's high time for us to look at component efficiency, majorly compressor, cost-effective heat exchanger, motor, VFD drives, etc. But at the same time, we also need to look at a couple of low-hanging fruits. There are still a lot of air conditioners who have completed their end of life but are available in the system. What we have to do with that? Eventually it is affecting the CO2 emissions, because these are largely ACs which consume 3,000 units, and now manufacturers have developed 500 units. They consume 500 units per year. So imagine the kind of improvement that the manufacturers have done, not only in terms of energy efficiency, but also in terms of refrigerants, which I just mentioned. So I believe we will look at the replacement programs which will be beneficial not only for consumers, but country as a whole, because we have a target of reducing net zero. 2070 is too long, but I think we need to look at 2030 targets, which is 8 years from now.
And by the way, I just want to throw some information. For your information, Rama is working on replacement of air conditioners, and we have developed a calculation where you'll be surprised to know that there are 40 million air conditioners which are there in the system, which has completed their end of life and are still available in the system, which needs to be replaced as early as possible. And we have prepared the data, and this data will not only help us to bring in the new air conditioners, which is of course creating the opportunity and growing the opportunity for manufacturers, but as I mentioned, it is a benefit for the country at large, because it will have new jobs, because these air conditioners will be built over and above what the manufacturing capacity is. This will also bring in skilled technicians, which is a major concern in air conditioning industry. This will also generate carbon credits. This will also help in avoiding some coal power plants or avoided power plants. So we have prepared the data in such a way, and it is in discussion with DE and Ministry of Power. And the second last topic which I wanted to touch upon is recovery and reclamation of refrigerants. Still, direct and indirect emissions are taking place in refrigerants, and in the service sector, these refrigerants are thrown in the atmosphere itself. We don't have infrastructure to develop reclamation centers, because these refrigerants, once reclaimed, can quality of 99.9% as same as virgin refrigerants. So I think we need to look at it in a very serious way, and I agree with the gentleman when he said that we need to develop some collaborative consortium for academia, policymakers and manufacturers to decide the way forward. And last but not the least, I think it's a high time for us to change the behavior patterns. We still set the temperature at 16 degrees and wear blankets in summer and sleep. So that necessarily needs to change. Thanks to BE, where all the manufacturers were called, and we developed a 24-degree default setting temperature, where a consumer, whenever AC is being switched on, it will automatically starts at 24 degree. Thanks to that, and one of the important points, which is my last point I want to cover, is we need to develop some policy on demand response or building management system. I think this can save a lot of energy. I would not say we are almost at the saturation of increasing efficiency, still there is a room, but I think it's a high time for us to talk about features which can save energy efficiency, which can benefit consumers at large, and which can probably BMS can be one of the points which all of us needs to look upon, as I mentioned on my other 3 points. These are the views from my side. Thanks a lot for hearing me out.
Okay, thanks Gaurav. This is very interesting, the information that you shared, particularly in light that the demand for just air conditioners, not even refrigerators, from about 2 million in April this year is projected to touch 9 million, an exponential rise in the demand for air conditioners in India, and the CAGR is projected at about 16% year on year. So you can just imagine there needs to be a transition built in from now as we speak, and not leave it too late when the volumes become so enormous that the transition becomes that much more expensive and unmanageable. So we have to take the lesson from fossil fuel to renewables. The transition was made rather late in the day. For air conditioning and refrigeration, we need to make sure that the transition is effected now, and therefore it's even more important that science and technology engage with industry and business. The next person on this.
I have a question.
Yes, sure.
I just wanted to ask you, where do you procure?
It is made in India. Yeah.
And I think just I wanted to add to Sir's comment. I think 9 million market is there, but still the penetration is too low. You know, we are at 8% penetration, and I think we have converted a lot of adversities into opportunity. But as I mentioned, still there is a lot of room for further more opportunities to come, and I think it's high time for all of us to come together and bring some policy on the table, you know, and develop some short to mid-term timelines and focus point by point to achieve those timelines to decide the way forward. Thanks a lot.
Yes. Yeah, I think it's good to know that you are using different refrigerants. So what is the global warming potential of that refrigerant?
Less than 500, I think.
So it's actually 675, but the good thing is that the charge ratio becomes 30% lower. What we used to use an R22 and R410As of the world, it is 30%. So when you multiply 675 by 70%, you'll get below 500.
Yeah, so I mean, I'm asking what is the disadvantage? I mean, is it expensive or all?
It's not at all expensive because, see, it depends on economies of scale. So as I mentioned, 90% of the Indian industry is using R32, and pardon me for that.
Yeah.
And this has primarily happened because we became the second company in Daikin to use R32. And then, you know, we offered free access to patents to many of the brands, including Blue Star. I remember, you know, we called Blue Star 30-member team in our factory to showcase R32 to the entire, you know, value chain of the manufacturing facility. So no one does that, but I think that's how we need to think in a different way. That's why we will be able to do things differently. But now, I think out of 9 million, almost 90% is R32.
Great.
But the good thing is that we can still continue this refrigerant for a couple of more years because HFC phase down is going to come into effect, I believe, in late 30s. So still we have 20 years to develop our own methodology and refrigerant and to bring something new for the consumers on the table. But as we also have a Daikin chemical division in Japan, they are doing some research on it, but it takes time. So I'm sure we'll find something on board. I think it's great news in the industry. Thank you.
Yeah, Gaurav, just thank you for your insight. Just curiosity-wise, two questions I would like to ask you. That what is basically the coolant you use? Are you aware of that? And then how your coolants are different from other industries who are in this, as far as refrigerant is concerned? This is a question where other industry people may also cover in their briefing. And second thing is a very common general question is that when we have our own house air conditioning, every year or 2 years a fellow comes for the servicing. He says that gas khatam ho gaya sab, and then he puts it and takes about some 2,000-3,000 rupees something. Is it that HFCs, CFCs, and is it released every year, that particular thing? And so then what would be the emissions of it?
It depends on the coils.
So, I mean, I'm just asking that because, you know, if it is leaking, let us say that there is some problem, but it's leaking. But after all, whatever is the gas, it is being leaked every year in all the air conditions.
Okay, so it is not for Daikin, it is for all. Okay. So thank you for that. So the coolant or the refrigerant, as I mentioned, we are using R32, which is a single base isotopic refrigerant. And the good thing is that the pressure level is same as R410A. And being a single component refrigerant, it is beneficial for the service also because they don't have to mix the refrigerant and do a balance and then use the refrigerant in the system. So that probably answers your question number one. Question number two is, I think you're talking about taking a countermeasure by paying 2,000, 3,000 rupees to a service technician. I would rather suggest you to take a preventive measure by coating those coils in advance so that leakage never happens. Probably I can talk to you separately on this, but that's a preventive measure which all of us can take. I am taking that in my air conditioning system. So I believe...
supplementary question is, let us forget it that, but what is there which he brings and can get, selling 2,500 rupees in the name of the gas. Is it so? Is it?
No. So
That's what I wanted to know.
So let me tell you, if you have let me ask you, which ACs you are using, don't tell me the brand, but which refrigerant AC you are using.
You won't know. You won't know the
If it is an R22, then probably,
It is LG or it is.
no, I don't want to know the brand as I mentioned.
Okay, fine.
Because my colleagues are also sitting, so. So ma'am,
90%.
I'll tell you, yeah, but it is, I'm not too sure if his AC, how old is his AC, but the leakage happens because of various issues. One, because of sulfur content, where your AC is being installed, and whether you are doing service on time or no, and probably these are the three major reasons. And I think the maintenance is very important while doing service, because if we are not doing service, I think the corrosion start taking place, because it is very important to clean them quite often, and due to corrosion, the leakage happens. And we recommend to use copper-based air conditioners, copper-based coils, because it extends the corrosion largely to the fins are aluminum. But copper tubings are largely copper-based. So probably these are the points that we need to take.
Phil, you had a question?
Yeah, I have a comment, and my first question is, do we have another speaker on the panel?
Yeah,
I think
we do. We have.
this is a really wonderful discussion. I have tons of questions and comments for all the speakers, and I just think.
Can we just wrap up the other two, please, and then we can have questions?
That's a good idea.
Yeah. Okay. So. Just two more, Phil. If you can be patient and sip some coffee on the side, maybe. Yeah. So.
Two more questions for.
No. Two more panelists. Yeah.
That's what I was asking. Yes, I wanted to hear the other panelists before we go to the.
Cool. So that's great. Okay. I just wanted to say that it's exceptional that we have got competitors in the air conditioning and refrigeration business in one room, which is unprecedented normally, because normally they do not ever like to be sitting around the same table discussing sometimes very sensitive information, and I know that through experience. Next we have Mr. Roshan from Voltas, which needs no introduction. It's a Tata company, and I leave the floor to Mr. Roshan.
Hi, good afternoon. First of all, I would like to thank NIAS to invite us for such an important topic. We may not be that expert in whatever has been talked from the beginning, from the morning, but it has been very, very informative, and we got to aware about the important things which affects our industry, and overall the kind of businesses that we are in. So it's a very important thing which we have been seeing it for last 20 years, and it needs a lot of deliberations, and and the topic today, what I wanted to discuss about is, from the science and technology, the kind of expectation that we have in industry, and what is the commitment, of the industry towards implementing those policies which will be coming from the policy makers. So we have seen in last 15-20 years there has been various phases of refrigerant getting phased out from CFC to SCFC and then now HFCs. If you see that period in which all these transitions happened, it has happened at the time when the volume was not significant, and as our other friends are also talking about, with the penetration level at only at 8%, 10% as of now, and the way the market is, is expected to grow, particularly what we are observing is that in Tier 2, Tier 3, even the rural areas, because of availability of power, Well, we all know that India more or less has made power available even for the rural, sectors. So the requirements of household air conditioners have increased, already it has increased and is going to expand in next 5-10 years. Is going to be very huge amount of requirements is going to come. So, it requires, and what we expect from the science and technology, eminent people who are putting a lot of efforts in finding out. I know it may not be a permanent solution, but the solution which is a long-term solutions in terms of having, refrigerant which is not having adverse impact on, ozone layer and greenhouse global warming, so that the transition happens, for a longer period of time, because the volume that what we are going to handle is huge, and the implementation will be happening at 3 stages. The first stage, the policy has to be there, and then second stage is the industry. Like us, we have to implement it in terms of making those products suitable for those policies, and then the third stage is, getting it installed and making people aware, general awareness to the people about this change. That is very important. So I was discussing with some of the colleagues today. This global warming or greenhouse gases should not be limited to the discussion of our technocrats. See, it has to be made aware to the people, general people, as much as what we are concerned. Because today we are talking about air conditioners, household air conditioners. We should be knowing that what gas we are using it. So the point is, it is so important if it is going to impact our environment that much. Awareness to the general public is equally important, so that there is a demand coming. It's a kind of bottom-up kind of push for policy implementation. So rather than industry pushing, that definitely industry will do it. We are all responsible corporates. We will abide by the policies, and in fact we do we take a commitment towards early adoption of all these technologies. But at the same time, if the requirement is coming from the people who are going to use it, so it becomes a comprehensive implementation of all these policies. So a lot of efforts have to be put on by the government, general public, to make this thing a kind of overall implementation. And the second important thing, which I think our friend also talked about, and some of our other members were talking about, is that how to control the emissions. Because there has been instances where people talk about gas nikal gaya, kind of thing. So as an industry, what we are trying to do is that because there is a scarcity of skilled manpower, in this industry. So as a Tata Group, what we are doing is we have opened a lot of skill development center for the technicians and service people. So they are, we are training the people. We are taking the people from ITI diplomas, and we are training them on all these aspects. And those people are not necessary to be working for us. It is open for them to take any kind of job. But our efforts is to have a pool of skilled people who can do a proper job. Even if you are taking an annual maintenance contract, you should be able to get those services in line with the requirement of all these things that we are talking about. That is the first kind of thing that we are doing it. The second important thing, which we are also in the process of implementation, we have done it for our large air conditioners, is that the remote monitoring system. So what we are doing it is IoT-based remote monitoring system. We put kind of system in all those equipments placed at various customer place, and we get a lot of data from operating data from those machines operating at different places. And it's a kind of it's a more than preventive. It is, we get an early sign of something going wrong, And before it really impacts the operation of the machine, our team contacts with the customer and try to address those things before something goes wrong with that. So there is a very established system that we are working with, and we are even trying to implement this methodology for our room air conditioners, so that because in the industry that industrial applications where the lot of technical people are involved, they will be still be able to find out what is happening with their machines. But in households, you will not be able to understand. Okay, so we are in the process of implementing that, and I think that would help us to get the data and try to address those issues in advance before something happens to the machines. The third important thing, as an industry, because we are both manufacturer of the air conditioners, we are also into a project business where we do a complete projects, including air conditioning, electrical, mechanical, everything. So I think a lot of speakers have talked about net zero buildings and the higher energy efficiency of the machines. So to control that energy requirements, so lot of initiatives in terms of designing of the system. If I talk about air conditioning systems, we use highest efficiency motors, IE4 motors. We also utilize heat recovery systems, because in air conditioning system that you will be aware that a lot of fresh air is required to be circulated in the system. Fresh air adds a lot of load, heat load in the system. So we try to utilize the exhaust air from toilet or other places and recover the heat so that the overall load on the system is lower. So all these, we are even trying to use renewables in the building so as to achieve higher rating. There is a body IGBC, Indian Green Building code, where we have to once we get some ratings on the energy saving, the buildings are rated, either it is a silver rated, gold rated, or platinum rated buildings.
Roshan, it's called LEED certification.
Yeah, LEED certification. Yeah. Finally, it's a LEED certification. So that has got a lot of importance in our industry. IGBC is the body, and LEED, it is called LEED certification. So the idea is to have all those system in place so as to get ratings on every parameter. There are some more than 15-20 parameters on which we have to achieve those energy efficiencies, and based on that the buildings are rated, and these ratings have a lot of importance because particularly in India, a lot of buildings are being occupied by companies from US, UK. So any building who has got this rating gets advantage. So getting a commercial advantage. So it is they are encouraged to use such kind of technology to get higher efficiency equipments placed in the system. Other than that, I think as I said, that what we would be expecting from the Science and Technology Center, Technology Department, is to come up with solution which we can work on and try to implement it in the existing installations, replacements, and even upgrade our technology to manufacture those kind of equipments. Because what I see as an opportunity today, because 10 years before maybe we may not be having a right technology, we did not have data analysis, we were struggling for a lot of data, which I think today a lot of speakers have shown how the data are collected, and with the advent of technology today, I am sure that the pace at which the earlier solution has been worked out. Today, I think I think somebody was also talking about from IIT that this has to be expedited. With all these things available, so we should get this thing done as much as possible. I know it takes time, But we are the stage, at least in Indian standpoint. I'm saying that because we are a fast developing country and we have a lot of things to do in the next 5-10 years. So I'm expecting that any sustainable technology long term, if we are able to have it, I'm sure that all the industry partners who are available today, or even in other forums that we discuss, we are all committed to implement it, even if it does not become mandatory. We do it voluntarily. That is the commitment that we can make it from the industry point of view. So thank you very much for inviting us again for this particular event, and we look forward to have deliberations on this in future. Thank you.
Thank you, Roshan.
Thank you, Roshan. It was very enlightening. Also, it gives a thought that possibly it's an idea for all the industry to get together and create a research hub for air conditioning and refrigeration within the country, especially because under the Atmanirbhar program you have the PLI scheme, which is intended to make in India, but globally competitive and puts India on the global map. So I think the government is already seized of the matter. I think our Honorable Prime Minister has got his focus in the right spot. It's now up to industry to get together to see how they can leverage this pathway. The next speaker is Sunil from Carrier, but I just want to inform the industry people that we have some time on our hands, because I believe the next speaker can't make it. He's probably tied up somewhere else. So if there's any other industry member who hasn't been able to speak and voice some of his concerns, he shall have the occasion to do so after Sunil completes his presentation. Thanks.
Audible? Clear? I think you used the mic. Yeah, good evening everyone. It's been a privilege catching up on the brains of a lot of intellectuals and quite insightful topics on which probably we are not privy to in our discussions, like you rightly pointed out, but I can differ on one aspect, that this is one platform where all of us friends and competitors from the industry would be working on commonalities and common challenges, and we wouldn't disagree more. So the perspectives, whatever we would be sharing, whatever we are sharing, and whatever my friends have shared in the industries, there's something very common. So I would touch upon certain few other perspectives which would give a brief idea on, where are we headed and what is the work in general the industry is doing without referring to the companies. I'm sure that all of us are doing the right things, the right work, and it's headed in the right direction. So my first statement probably might give a different perspective to this. Refrigeration and air conditioning industry in general globally contribute to 10% of CO2 emissions. That's the fact. And when you break it down, the way the work is currently progressing. So all of us mentioned about Montreal Protocol, wherein we had the accelerated phase-out schedule for HCFC refrigerants, the first phase, and now we are in the midst of the second phase, wherein now we've got the Kigali Amendment also, which brings in HFC phase-out schedules as well, depending on the baselines. That's how the work has been progressing. Giving a perspective to my first statement now, still India is one of the countries where it has the lowest cooling access. The global average for energy consumption for air conditioning happens to be about 270 kilowatt hour, whereas India is at 70.
almost 25% of the global average. US is at 1,800. So the drive which is happening globally is, there is no guess to that, and why we are part of that. While we chose to be advancing in this direction, a lot of drives and a lot of initiatives which is happening, I would say that we are proud to be doing this quite in advance on whatever work currently we are doing. So while some of our mates here mentioned about the cooling action plan, the India cooling action plan, which is currently the guiding document for So the India Cooling Action Plan document is the guiding factor for the industry currently, which was conceptualized and documented in 2018, which gives these statistics as well as the growth trajectory of India, which is going to happen in the next 20 years. So 20 years is a reference document for that. So while we break up into the segments or the product segments as per this, the residential segment is slated to grow about 11 times, that is 2018 to 2038. The VRF segment is another growth segment which is again about 12 times. And then comes the chiller industry, which is about 6-7 times. Similarly, if you divide it into the application sector, the building sector would have similar growth path, the cold chain sector would have 5 times. Again, the transport refrigeration would have some 7-8 times. This is how the industry is slated to grow. Currently, where the industry is, the product mix of all the companies together in India, if we were to continue with that product mix, we would end up at around 120 gigatons of air conditioning capacity, energy consumption equal to air conditioning capacity in this 20 years. So the direction is, as per the ICAP, is to reduce it by 30%. So that's how the industry is working to change the product mix in terms of bringing in new products with new refrigerants, trying to phase out maximum of HFCs in due course of time, which gives us an opportunity to work on different refrigerants. So let me tell you, like our friends were talking about, Gaurav was talking about R32, Roshan was again talking about new refrigerants. All the companies in the industries have already developed a lot of products in different product baskets working on alternate refrigerants. These are already available with most of us. Not now, this has been probably available with us for the last 3 years. R32 has been available for many years now. We have the HFOs now, hydrofluoroolefins, which is air conditioning equipment, which is available with in the large product segment. So the advancements, while they are happening, the challenges. Yeah, the challenges what we face is probably multifold in terms of investments coming into business, in terms of investments already done for the business, and we having to change things in the products, sometimes in a very short span of time, with regard to changing regulations or changing requirements in the industry. To cite a very simple example of recent times, we have the Bureau of Energy Efficiency rating, which is being applied on the chillers. Specifically, this is following, you're all aware that we came up with the rating program for residential air conditioners somewhere in 2007, so it's been 15 years now. That's worked very well, and now we have star ratings, we have high efficient products in the residential segment, which has supported this initiative. In the air conditioning segment now it's happening with chillers. Now last couple of years this program is getting pushed out. At the same time, there are some changes in terms of the criteria of how the program is going to be implemented also, which has happened in a couple of years. So the challenges with manufacturer is that we've already done these investments. All of us even tested these equipments. We were about to publish data. I mean, all these cost money as well. There is revenue which is being spent from the companies, but then we get into a position where we have been asked to do it once again. I mean, that's currently the state. So that's one challenge which we encounter. Similar are the challenges if these sensibilities with regard to the life of the product, serving the life of the product, and how you scale up the developments, the evolution in the product with regard to any change, whether it's with regard to refrigerant or whether it regards to technology. While we spend millions across the globe, all of us, trying to implement this, trying to do research and development and trying to get the best out of these products, these sometimes really hurt us in terms of trying to implement and getting the right products to the market. The second challenge what we have in India is that while these are kind of regulated in developed countries like US, Europe, while we have a phase-out schedule, I mean, the regulations are still very high. I would say that there are sorry for that. So there aren't any regulations which helps enforce this or takes it to the user. So users still go with a lot of options depending on deliberations with regard to their project implementation or costs or whatever is available at them or to them at their disposal. This also leads to a factor that some of us, the companies in the industries tend to still promote products which are probably not being used. I can say that among all the air conditioning manufacturers currently operating in India, there is one manufacturer who still continues to promote HCFC 123, which none of the other manufacturers does. So this is because of clear lack of regulation and clear lack of understanding, while this is also currently at the end of the phase-out schedule. And very soon, these systems will have to be retrofitted with a drop-in refrigerant, as the community calls it, while the industry knows that there is no drop-in refrigerant. Drop-in refrigerant always comes with compromise on energy or compromise on efficiencies. So as a manufacturer, what we work on is not basically to look at phase-out of greenhouse gases or ODS based refrigerants. The approach what we tend to take is TEWI, which is total environmental warming impact, which if you break it down, the direct emissions caused by this is 2%, whereas the indirect emissions is 98%. When I say indirect emissions, it's the energy what is spent in manufacturing, in delivering this equipment, the air conditioning capacity, and what's the energy which is absorbed by this, and what it translates in terms of emissions. This has got a far outreach than the refrigerant leaks what we were talking about in terms of. So how the ICAP currently works and how we would like to work is that rather than looking at we have all moved from the ODS depleting, ODS zero potential, now it is global warming impact. So it's not about low global warming impact, It's about using the right refrigerant, which actually helps us to manufacture the right equipment with the right footprint, which actually balances this. So not all refrigerants, what is currently prevalent, even if it is HFC, is going to be not to be used for future, or it is bad. What we would find out is that if we transition this to a new refrigerant or an HFO or any other refrigerant which would come up in future, we might have to produce a larger equipment. It might take larger energy or larger manufacturing costs, even though the refrigerant amount must be less. So I mean, this is a balance which we have to take. So this is all about harmonizing efficiencies along with what kind of refrigerants, what we use, how do we balance out the global warming impact, and comes out with the right equipment. And of course, following with whatever my friend said, the awareness and the training levels of the industry with regard to how you install the equipment, how you make sure that the equipment serves maintenance-free, minimum of gas leaks. So as companies, all of us and the communities, the history communities and the ASHRAE communities are doing a lot of initiative with regard to trainings as well as technician certification programs. We are responsible for doing this. I mean, we are making our partners responsible for this so that we contribute to the industry that way. I mean, so factors wherein we can be of a lot of help and support with regard to development. We are continuing to do that. Continuing to do researches on refrigerants, spending money on technologies, developing new products, energy efficient product. This is happening across the board from the industry. Yes, one interesting thing what in response to the question, what we would, the knowledge on emissions, while the magnitude still with regard to the air conditioning industry is less, but that would certainly help give us a direction in terms of knowing this. While as company at Carrier, we ourselves have ESG goals as well as sustainability goals with regard to how we measure this. I mean, we ourselves are trying to find mechanisms wherein we find out what is the consumption of refrigerant and how we are contributing to this, while we never thought about this till now. But we are trying to do this, and I'm sure that we'll come up with something very soon in this way. And whatever support we get from externally would definitely help. So I mean, we continue to do this, we continue to work this, and regulations coming from industry, coming from government, support in terms of measurement and verification, and of course investments from this will be a multifaceted teamwork which will take the industry in the right direction. That's all from me. Thank you.
Thanks very much, Sunil. Very enlightening presentation as usual. It's very interesting to note that as industry is concerned, I think you all have been very proactive, which is really good. And it's very important as well to drive policy. I think we will now, I will give the mic to Dr. Beg to take on the next session, whether it's summing up or if you have questions, yeah, sure, briefly. Yeah. Because we have to break at hand. Yeah. So because we need about 10-15 minutes for summing up.
Yeah. I think one thing is coming clearly, and first of all, I think I should congratulate Gufran. I think Persis said it very well, that getting manufacturers at one place to talk about it is an extraordinary achievement for the organizers. My questions are very specific. All of you touched upon energy efficiency, but I feel that more than the refrigerants, of course refrigerants are important, you should be talking about energy efficiency in terms of emissions, because energy efficiency improvement reduces the emissions of GHG.
unless it is coming from solar energy or something. And I think, as I think you said, that 10% is emission comes from refrigerants, and rest of it, 90% emission comes from energy efficiency. So, have you thought about, this is probably to Gaurav, let's say, because I don't think we have time to get the input from all the three of you. Have you thought about your what is called as a environmental responsibility to reduce the emissions coming out of the energy consumption? And are you developing a scheme so that many of the consumers come only to you because you are taking that responsibility of energy efficiency and reducing the energy, emissions due to the energy?
So, Dr. Shumte, it's actually called EPR, Extended Producer Responsibility.
Right. Very good.
So, thank you for the question, Mr. Shinde. As I explained, the program which industry is proposing to the Government of India on the replacement of air conditioners largely captures emission also. Captures emission because, as I mentioned, the product which were 10 years back that were installed and used were consuming 3,000 units per year. Now, many of the brands have ACs which consumes 600 units. So largely that is contributing to CO2 emissions because of the gain in energy efficiency that all of us did by, And this is one point, and I explained it earlier also. This will not only save CO2 emissions through energy efficiency, but it will also help our more skilled technicians to come into the society of air conditioning and refrigeration. It will also generate carbon credits. It will also generate e-waste, because we also have a national targets to meet the e-waste timelines and overall targets. And broadly, I think I can say on behalf of industry and all the manufacturers, if I get permission from them, India has demonstrated a very successful program of inverter air conditioners. I remember 2013 we were using 3% only. Now the market is almost 70%. 70% in just 9 years, So that largely is based on the efforts of Government of India, of course, and also the manufacturers. We gave awareness, technical trainings. I think my colleague from Voltas were also touched upon that, So we also have some 20 center of excellence where we train these people, in our COEs. And these COEs we have not created. They are largely institutes, Osmania University, PUSA, then IITM Gurgaon, many such renowned places are also created as center of excellence. And also we have created one manufacturing excellence, which is called Daikin Japan India Manufacturing Excellence Institute, which is based out of Nimrana. And this is a setup based on the collaboration between Honorable Prime Minister Modi and late Prime Minister of Japan, Mr. Abe. And the foundation was laid, and in that institute, we train on the Japanese way of manufacturing to the students. There is a dedicated course. So I think efforts are already onto it, but as I mentioned in the beginning, I think the gentleman also touched upon, everybody is working in silos. I think it's very high time for all of us to work as a collaborative way, because I think I can go on and on, so probably I have to stop myself. Yeah. So, because due to shortage of time, probably we can touch upon separately.
You ended your answer with the kind of a situation which I was coming to. Yeah. That as a support to the whatever we are planning of your consortium, maybe there is a sub-consortium which supports you from the industry. in terms of providing emissions due to the energy efficiency, due to the direct ones. Because you did mention a huge problem, and I think Gufran, you may like to take note of it. But he said about 40 million outdated ACs are going to come out.
40.
40 million, right?
This is our data which we estimated.
Yeah.
But I'm sure the data estimated by some of the NGOs will be even more.
It's a huge number.
Yeah, absolutely.
That will emit slowly, if not properly taken care of, because the HFC.
Yeah.
So I think there is definitely a connection between a scientist or policymakers consortium along with the industry consortium.
Absolutely.
So all three of them can come together and sort of support this kind of initiative, which will help both ways.
Yeah, Gufran, now you have to rescue Phil, please.
Yes, I think he is, for last 24 hours, he is not slept. And I think we all are exhausted, I think we all will agree.
Yes.
So we are not going to have a very elaborate wrap-up for summary of finding, which will leave it to tomorrow. But what I wish at least, which is there in the agenda for next 10 minutes, maximum 10 minutes, so that, by the way, next speaker, he got some very important commitment of Government of India, so he has gone, so this 17:30 to 18 and the talk is not going to be there. So we will have time to freshen up before we go for our celebration. So what I wish that number one I can start is that I think with all deliberations and what we discussed before lunch, that measurement based emission estimate will add tremendous value to the traditional bottom up approach for emission development. Number one. Number two, we must get our own Indian measurement system and a emission management system. These are the 2-3 things I think all of us in this room agrees to that. And finally, that knowledge based is going to be translated into the recommendations for those ozone less depleting substances which are not even providing a lot of global warming potential. And I think that will cost effectiveness and all is going to be there. So we will do that. But what I will before means after full talk that maybe whoever very brief what as a recommendation or a summary you would like to tell which may go to the government for as a recommendation or anything very preliminary, which we will put in that because it is being recorded in this one. And before I go to the field, I just like to tell that those people who made a presentations today and whatever we would like to get your feedback, whether we can share this feedback because there are many demands that people like to have from industries and other, so that you can privately send a mail to Murphy and do. Over to Phil. Your mic is muted. Phil, your mic is muted. Phil, your mic is muted. We can't hear you. Oh, yes.
No.
Oh. Again, gone again.
Can you hear me now?
Yes.
I was saying that it would be wonderful. I've shared my slides already, and I would hope that the presenters would share their slides with us so that we can have them for the record. And I'm very grateful to Gufran beginning with the summary. I think Ravi asked before lunch, and Gufran just repeated, that we are hearing in the room some endorsement. Actually, Ravi, I think actually said, please say yes if you believe it, that we see that measurement-based emission estimates have value to add to the state-of-the-art bottom-up approach. and that this would be something important for decision policymakers to have this advantage, this information in India. Another thing that I wanted to add, which I hear over and over again, especially from this most recent panel, and I've heard it repeated during the day, is that it's not even just engagement with the users and decision makers, but as I was saying, one of the principles of NIAS, the initiative that I co-chair, is that we train users, meaning that we sit with them frequently to help them to know what information they need to overcome barriers to achieve their goals. And we're not always going to have that capability. The kind of science-based, measurement-based information can do many wonderful things, but it can't do everything. And so we need to know how to target our efforts and where we can really make a difference in the policymaker, decision makers' lives, whether they be government or an industry or wherever they may sit and whatever they may manage. How can we help them sleep better at night? But the one thing I want to add to this is not easy. It's easy to say, and it's something that I think everyone in the room can agree is important. And we've heard it over and over again, but it's difficult because these people, decision makers, leaders of states and cities and the federal government, they're very busy people already, just trying to do their day job, trying to, never mind innovation and new information and new technology. So we have to really make an effort to get out of our laboratories and to get in places where we can meet. That's what's so rewarding about a day like today, to have this great diversity of thinkers and doers coming together in a forum like this. And we really named this meeting to build a consortium of this diverse community, and we hope that we can keep it going and keep this conversation going and acknowledge that it is hard work. It takes all of us a lot of effort to have these very meaty, very difficult conversations. And so those are my two main points to amplify what Gufran and Ravi have said about can we get that endorsement for the fact that we see important value in investing in translating the research successes that we've shown with measurements and how that top-down adds value. We can summarize it by saying the atmosphere can fly. As long as we have the skill and knowledge to tease out the information that it has there, it's an important layer to be added to the activity data and emission factors. And we've seen over and over again today how it adds actionable information. It creates granular and space and time information that is valuable because it enables action. And I think that's all I'm going to say for now. And I think one last point, I think, is we heard that it might be easier if we start off by focusing on the halogenated industrial gases, the so-called F gases. In many cases, they're F gases, fluorinated gases, but there are more. And I think those gases that have the ability to help us build trust and knowledge of how we work together in this diverse community and demonstrate the power of the science-based information as a guiding tool to make valuable decisions and more efficient decisions, and to track the efficacy of the decisions and the policy over time. That's it.
Thank you, Greg.
Thank you, Will. So is there, maybe some, I will be happy if the people in this can make very brief the statement which we may include in the recommendations. Madam, yes, Sujita.
So, isn't the statement for the recommendation, it's very clear that there are data gaps and we need to strengthen that in terms of measurements.
Mike, because it will not go to YouTube.
Hello. Yeah, so not exactly a comment. I support the fact that there are gaps in data, and of course, that's one thing that we need to basically focus on with regard to getting the right institutions across the table in terms of contributing in different ways and helping support densify that information. But I think it was for the last panel where I had questions related to IPR issues and copyrights and patents that the private sector has with regard to sharing of technologies, and how does that come in between when we talk about the large public good in terms of reduction of concentrations of greenhouse gases and ODS substances. But also a second question with regard to the industry, with regard to net zero goals that the industry is now declaring. And when you talk about multinational companies, how do these companies operate? And when you say net zero, is it net zero in India, or are we talking about multinational companies looking for carbon offsets in different countries? So modes and modalities of that, because that will then help us know in which direction will the technology be pushed further in terms of discussion and taking the next step forward.
Thank you. Is there anyone?
I'm very sorry to interrupt. I forgot one thing that I wanted to get on the table for this wonderful audience to consider before we adjourn today. And that is, we've been talking about a very important industry, one that's going to grow exponentially, and the need for cooling. But one thing I wanted to see if anyone had any thoughts about in the room is, I've been hearing in the news and that there's potential for India to begin for chip manufacturers, and all around the world you're seeing more and more growth of this industry, recognizing the need that we've just seen in the supply around the world. I'm wondering, that's a whole other suite of emissions like SF6, for example, or NF3, which in places where semiconductor industry is large, including the US, we see growing emissions of these gases. And so just one other thought in terms of, an industrial audience is in this area of semiconductors, and is this going to become an increasingly important issue in India? That's just one thing I wanted to I had forgotten to mention. Thank you.
Yes, please.
Just adding to what Phil had said and also hers, I think I can conclude by saying that there are various sectors of emissions, and all of them need to have sub-working groups so that they can track the, first of all, the technology transition that is happening vis-a-vis the fluorinated chemicals that we are using. And next is that, of course, measurements need to be done as well as tracking of activity data to do the conventional greenhouse gas inventory as well, because our reporting requirement will require us at least for next 10 years to do that. And simultaneously, this mechanism of measuring it through satellite or monitoring can be an MRV process that can support that system. So a multi-pronged approach and a multi-sectoral approach with the technology and the industry being tracked of how it is moving, I think that is the way forward. And so I'm assuming that there will be 4 or 5 working groups focusing on different sectors and tracking the different industrial gases that we need to track.
Thank you, Sumanna. Anyone else? Very briefly, yes, Dwayne.
Actually, the industry probably that we have talked about, we have started as a scientific point of view, but I might make queries from the industry, and that the industry has the data for the how many basically represent and what are the capacity has been basically given to the use in India. Do they have the data for the emissions? Basically, like initially they have basically calculated the emission factor or emissions as a new instruments, but as the days goes on, what will be the emissions part? As you said that is after 2-3 years that the gases are basically there. So that when you calculate the part, emission estimate, So that part must be taken care, because when we do the emission total estimation, we do that how much basically coolant or refrigerant amount basically is there in the refrigerator. But with the efficiency of the your time of the refrigerant has been changing. So that must probably not only the gases amount in this, the refrigerant efficiency in this must be basically taken care of the part, and that data only can be given by the industry. That's
Yes,
the
that would be a very rich thing. You wanted to speak? Yes. Okay, I think so. Anybody last? Any other comments? Fine. So if that is the case, I would like to just tell that